Hello, Mr. Hausler here. So this is for Chapter 8, Quadratics and Inequalities. What we're going to work on is how to graph systems of inequalities. Systems of inequalities is just two or more inequalities graphed on the same graph, and the solution is the overlap, the intersection of solutions. So we have to graph both of these guys. This one's going to be a parabola because it's a quadratic. This one is going to be a line because it's in a linear equation, y equals mx plus b. So for this, I'm going to want to find those x-intercepts. The y-intercept is a -7. I may want to also find the line of symmetry so I can graph this parabola. So I'm looking at this, I can use the x-box factor. A times c, got to be equal to b. So a times c is a -14, b is a +5. So I'm trying to figure out what goes here and here. When I multiply them together, I get the -14. When I add them together, I get a 5. So that's actually 2 and a 7. I'm going to make that be +7 and a -2. Because if I multiply them, I get this. If I add them, I get this. So I've already factored this guy. I can use the Xbox method, but to figure out my dimensions. So 2x squared minus 7. And put the -2 there and the +7 there. And we're working on finding our factors. Go down this column. The greatest common factor is the 2. Sorry. Forgot my x's here. Which makes that 2x. Okay, greatest common factor here is going to be 7. Probably going to have to use a negative somewhere, either -2 or -7. We'll have to figure that out. Find the area here, 2x squared. So I'm going to need an x right here to get 2x squared. To get an area of -2x, I'm going to have to multiply by a -1. -1 times 7 gives me -7, x times. Good, everything's good. So those are my factors. I'm going to have 2x minus 7, or plus 7, and x minus 1. So now I know the roots are going to be at, right here, if I set this equal to 0, 0 property product, I'll set this equal to 0. I'm going to go different color for you guys. 2x plus 7 equals 0 could be one of the roots, and x minus 1 could be the other root. This one I just know it's going to be x. It's 1. This one I'll do the math. Subtract 7 on both sides. 2x equals -7. Divide by 2 on both sides, x equals a -7/2, which is basically a -3.5. So those are my two x-intercepts. So knowing that, I can actually keep this scale as 1s. I'm going to call this -5 and this +5. I'll call this a 5 and this a -5. I can start graphing this parabola. I have a root or an x-intercept of 7 or 1 and a -3.5, so 3.5 right there. I'm going to go ahead and erase this. You guys can always rewind the video if you need to see this. I also know crossing through the -7. Oh, so I'm actually going to adjust this. I'm going to have these guys count by 2s. The y-axis is going to count by 2s, so I can get to that -7. Okay, now I'm going to just look for that line of symmetry. X equals opposite of b over 2a. So I'm calculating line of symmetry. X equals -b divided by 2a. So opposite of b would be a -5. 2 times a would be a 4. So x equals basically a -1.25. So at -1.25, I can expect a line of symmetry. Or it's also going to be where this parabola, being that it's a parabola that opens upward, this is going to be my minimum. So I'd expect it to keep coming down here until it hits negative 1.25. I am going to graph this with a solid line because it has an equal sign. And then just a mirror image. That's why that line of symmetry is so helpful. It helps us make a mirror image and reflect it on the other side. So now in brown, I'm going to work on this. This is y equals mx plus b. So that's my y-intercept, and this negative 3/4 is going to be my slope. So I should be able to graph this pretty quick, but it's going to be graphed with a dotted line. So I'm going at 5. So these are counted by 2, so 2, 4, 5. And I'm going down 3 over 4, so be careful with this. The x-axis is counting by 1s, and the y-axis is counting by 2s. So if I go down 3, that's going to be here, because that's 1 plus 2 more, 3. And then over 4 would be all the way over to here. Do the opposite of that, up 3 to the left 4. You can kind of see my line. I just have to make it dotted this time. So there we go. I got both boundary lines graphed, but now I have to cover the shaded regions. So if I'm thinking here, it was supposed to be greater than, so I should have everything above this parabola. And right here, it's less than, so that should be everything below the line. So above the parabola looks like this. Below the line looks like this. Okay? Now the solutions are only the intersection part. That's all that the solutions are. So this is actually the area of my solution, right there in orange. I don't know if you can see that well. But any dot that is living inside this orange section is an answer to this system of inequalities. It'll be true for this and true for this at the same time. So those are our solutions there. Anything in there with the orange.